We have made it. This is the last lesson in our geometry course. So I have a chart typed out for you here. I'm not going to go over it right now. It's just going to tell us everything that I'm going to talk about, all of these. But there's 4 different places here. Do you see that that angle is the center of the circle? Central means same. This angle's got a vertex on the circle. In that case, that's the 2-to-1 inscribed. And today's concept is about what if you had an angle that is inside the circle or outside the circle. So here's what we'll do. Do you see they ask us to find x in this picture, and he is on this angle right here, and this is the vertex. So I'm going to be a broken record and just repeat myself. The main question that I'm asking is, where is the vertex? Outside the circle, inside the circle, on the circle, or the center of the circle? Where is this red dot? He is inside, and are we cool that he is literally not the center of the circle, so he's just inside the circle? Well, here's what we do. We need to find the measure of the arc that's contained by that. How do you feel? It's that pink one. You see that that pink one is contained by that green guy right here. And then I'm going to make up a phrase that's probably wrong. It's not correct, but I think we'll understand it. Like, how do you feel that this dude right here is like a vertical angle to the x that they're trying us to find? Like, those are vertical angles. That actually is a term, but what I'm going to do is talk about this pink arc right here. Isn't that the arc that's contained by our guy's vertical angle? I'm going to call him the vertical arc. That's really not a term, but those are the arcs contained by those vertical angles right there. And here's what we do. Do we know both of them? Yes or no? Do I know both of the arc measures? Inside means add. We are going to add those together. Please show this work. I do want you to show the work. We're going to add those together. And all we have to do is average those. And to average 2 things, don't you just divide by 2? And that will equal x. So if we show work like this, it will make the harder ones of these easier. But to punch this in, you have to punch it in properly. So do you see how there's stuff to do upstairs in the numerator? We've got to add those up. Just do that and hit equals. So 40 plus 162, and please hit equals after that. Otherwise, you got to put all that junk in parentheses. So did you get like 202 back for that? And then what do we got to do? Divide by 2. So inside means add, and x turned out to be 101 degrees. It's just that simple. If there's an angle inside the circle, you add the 2 arcs contained by it vertically and divide by 2. You're just averaging those. So inside means add. Let's try that again. They want us to find x, and if you ask yourself this magic question, where is the vertex? Inside, outside, on, or center? Where is the vertex? Inside, it means add. Find the arcs contained by it vertically. So are we cool that that 200 contained that blue angle that has the x in it? And this is its vertical arc right here, the arc that's contained by the vertical angle. So show me the work, because it does get weirder. Inside means add, then divide by 2, and that will equal x. So that's going to be 266 when you add 200 plus 66, and then divide by 2. Did you get 133 degrees back? Other things I need your help with is I just kind of made these pictures free-handedly. And if it's like, Mr. Farnstill, I got 133, but that doesn't look like it measures 133, it's going to be okay. Some of these angles don't look like what they're supposed to look like based on me making this worksheet in a hurry. Trust your math was right, not the way the picture looked. There's even one on homework we got to delete because we get a negative answer, and I was a bad boy, didn't check it out. It's like, that doesn't make any sense, so we got to omit one of those questions. Cool, but I want you to say the word add back when I ask you this question. What do you do when the vertex is inside the circle? You do what? Inside means add. Cool, inside means add. Then, of course, got to do the divide by 2 thing, right? So let's do that again. Where is the vertex of this bad boy? Inside. Let's find the arc contained by it. Ooh, they didn't tell me that, but can we figure it out? Do we have all the other arcs of the entire circle? Right, so cool, I'll let us do some math on that. 360 minus all of those. And how much did we get? How much, Mike? 194 degrees. So put it in the picture. Is that cool? I did 360 minus 86 minus 20 minus 60, right? And then who's the arc that I need that's vertical to that one? So there's a 60, a 20, and 86. Which one do we need? Are we cool with the 20? Right, those two are vertical to this guy. So we'll add them up with a pen, not a highlighter. 194 plus 20, then a little divide by 2, and that will equal x. Inside means add, baby. But please do the numerator first. Hit equals, then divide by 2. And I got 107 back. Throw a little degrees on there. And boy, that's just probably a little way too simple, wouldn't you agree? It's really not that complicated. You're adding two things up and dividing by 2. Because here's the question, what were the two? There's three things that we need. We need 1, 2, 3 things in this equation, because the divide by 2 is just there. And what were these guys? Arcs or angles? Who were these guys? Arc measures or angle measures? They are arcs. Check this out. Do they give you an angle measure right here? Yes or no? And here's the first question. Where's the vertex? Inside, outside, on, or center? Where's the 75 degrees at? He is inside. But the weird thing is they are asking me to find this arc. And isn't the 60 degree contained by that 75? Since it's inside, guess what we got to do with the arcs? We got to add them up. But see, we got to be careful because it is the end of the year and we get a little tired. Every time it's arc plus arc divided by 2 equals angle. I got to add my arcs up. So how do you feel it is like x plus 60 divided by 2 equals 75? Does that make sense that this 75 has to go off to the side because he's the angle measure and that's what they have to add up to be? Are we cool with the setup? And now let's make something ugly not so ugly. Nobody really cares for this stupid fraction. Let's get rid of it. How do you get rid of divide by 2? I'm going to multiply both sides times 2. So if I take this side times 2 and this side times 2, don't those cancel each other out? And the x plus 60 is going to come down. And you might need to just punch in 75 times 2. And whatever that turns out to be, you put him right there. But is that cool that I just got rid of the stupid ugly fraction by multiplying both sides by 2? And then one last little bit of algebra. It can happen to the best of us. How do I move this plus 60 over to the other side? We got to do the opposite, right? We got to subtract 60. So is that 90? Is that right? 90 degrees. Cool. Those were all inside the circle. Inside meant add. You just got to be careful. What did they give you? 2 arcs or an arc and an angle? This guy is the angle. He's got to go over here by himself every time. Cool. The angle goes by himself. And of course, there's only one thing left. Check out this angle right here, my friends. Where is the vertex? I'll put a red dot on it. Inside, outside, on, or center. Where is the vertex of that guy? He is outside the circle. I'll bet we're smart enough to know if inside means add, guess what outside's going to mean? It means subtract. You got to find the 2 arcs contained by it. So how do you feel about if I get my highlighter pulled up? This 84 degrees is contained by it, but it also is right here, right? There's another one because those are secants, like they go through the circle twice. So we just need to subtract them. And here's a rule. You got to always take the big one minus the small one. It's like there's an 84 and a 26. You got to take the big one minus the small one. So we'll set it up like that. 84 minus 26. Guess what else we got to do to it? Same thing we had to do last time. What do we still got to do? Divide by 2. And that should equal the angle. Do you see how the angle is still all by himself? And it's a real basic game. Outside means subtract. Inside means add. So we will do 84 minus 26. I got 58, but you got to divide that by 2. And how did you feel about getting a 29 back for that situation? Questions? If you talk yourself through it, it really, really isn't that bad because you're looking for an angle and you're asking yourself one question. Where is the vertex? Inside, outside, on, or center? Where is this in relation to the circle? He is inside it, outside it, on it, or the center of the circle? This is outside the circle. Like here is the circle. Isn't that on the outside of the circle? So I need the 2 arcs contained by it. That would be this 120 right here and this 45 right there. And what does outside mean? Same, 2 to 1, add or subtract. Outside means subtract. 120, take away 45. The weird ones, you got to do the divide by 2 trick, and then that should equal x. And x is all by himself, so I just got to punch this junk in. The proper way to do it, if you're going to try to do it all at once, is to put the upstairs in parentheses. I'm not a fan of that. I just like to figure it out first. I do the 120 minus 45 and just hit equals. That takes care of the parenthesis part. And then you divide by 2. It is okay. It's decimal. Rock on. 37.5, is that what it said? Yeah. Cool. So last one of these that I'll really talk us through. It's all about where the angle that they're dealing with. We don't care about the arcs, where the angle's vertex is. Inside, outside, on, or center. Where is the vertex? Outside. So I got to find the 2 arcs contained by it and subtract them. Oh no, one of them is an x. Who cares? We'll set it up. Guess who goes all by himself? It's the 40, because he is an angle measure. The 40 is going to go all by himself. And cool question for you. Who's bigger, the 60 or the x? Who do you think has to be bigger based on the way the picture looks? The x is, because the angle keeps getting wider and wider and wider as we go out. So we have to do x minus 60 as opposed to 60 minus x, because it's got to be the big one minus the small one. Don't forget that we got to do a darn divide by 2, and shouldn't that equal the angle? I want to slow down a little bit. We're cool that it was outside. We did subtract. Got to do the divide by 2, and the angle is all by himself. We all good with that? This sucks. I need to get rid of him. People ask why. They're like, why didn't we do that over here? Because aren't we looking for x? And x is inside the fraction of a mess, right? So we want to get that x all by himself. I need to make that divide by 2 go away. How do I make that divide by 2 go away? Multiply both sides by 2. So x minus 60 comes down, and 2 times 40 is 80. Rock on. And then, of course, small little brain fart could happen. We don't want to subtract 60 from both sides. He is negative. How do you move him over to the other side? Add 60. Cool. That's basically it, minus a few little weird things. You see there's a bunch more, but all of these were secants. They went through the circle twice. It works the same thing if you have some tangents. You see this guy right here is a secant because he touches the circle in 2 places. But this guy right here actually only touches the circle in 1 place. He's a tangent. They all have special names like the secant-tangent theorem or the tangent-tangent theorem. I could care less about those names. It's all down to this. Where is the vertex? Inside, outside, on, or center? So here it is. Let me highlight this guy real quick for you. Do you see the angle that I found in the picture? Now we got to start thinking. First answer this question. Where's that vertex? Inside, outside, on, or center? That is on the circle. So no add, no subtract. It's either the same or 2 to 1. And if you can't remember, that's why I made that chart on the front of your worksheet. What do you think when the vertex is on the circle? Same or 2 to 1? 2 to 1, just like our skill check was today. Do you know the arc contained by it? I forgot to go over that. We sure do. How do you feel that that green arc is 75 degrees? He's inside of there. And what do you want me to do with the 2 to 1? Multiply by 2 or divide by 2? Don't we need to go backwards and divide by 2? So we'll get another decimal. But it's just the simple game of where is the vertex. Regardless of how complicated the picture gets, if you can answer that question, you'll get yourself started, 37.5 degrees. We'll just go ahead and put that in the picture.